Thank you. Am I audible at the back? I can hear myself. I can hear the echo, so I think it should be good. All right, welcome everyone. Good morning. I know it's your first session, so let's get the energy rolling. It's my first session too. So today we're talking about how you can connect your network to AWS with hybrid connectivity solutions. I'm joined today by Rizwan, who will be coming up later to talk about some solutions. My name is Sid. I'm a principal solutions architect with AWS. I've been with AWS for over 8 years now, and I'm happy to be talking about hybrid connectivity with you guys. Now, why bother talking about hybrid connectivity? Well, it's because traditional enterprises are complex. Now, depending on the type of industry, you might have different physical sites. You might have warehouses, factories. Typically, you have data centers, branch offices. And you might have mobile devices, end-user mobile devices as well. Now, you want all of these connected together in a secure, scalable manner, and that is complex. Now, customers are moving their workloads to AWS, but 86% of the infrastructure spend is still on premises, while 88% of the customers have a cloud-first strategy. What does this mean? It means that it's a hybrid world. You have applications which are being migrated to AWS. You're building applications on AWS while you still have a lot of on-premises presence. And it's a journey. It'll take time for customers like yourselves to move your workloads entirely on AWS and be cloud native. Till then, we need to talk about hybrid connectivity. How can we connect your AWS infrastructure to your on-premises networks? So the vision is simple. AWS becomes the hub. AWS connects to your on-premises infrastructure, whether it's your factories, it's your data centers, it's your branch offices, as well as AWS can be the glue which connects your sites together. So if you're bringing up a new factory and you want to connect it to your data center, you can use AWS's global backbone to connect your on-premises infrastructure. And we'll talk about how you do all of that in this presentation. Right? This is all what the presentation is all about. So if you look at the network transformation pillars, or the hybrid connectivity network transformation pillars to be more accurate, we have connectivity between AWS, within AWS, to your data center, branch offices, connectivity to internet. And connectivity to data centers and branch offices is what we'll be focusing on today. Now let's start by understanding how you run infrastructure on AWS. Right? Once we understand that, then we'll figure out how you connect it back to your on-premises. AWS provides you with global infrastructure, which consists of regions. Within regions, you have isolated availability zones. And you also have 230-plus points of presence. This is a global edge network for low-latency access of your applications to your end users. Now, when you deploy your applications, you are going to deploy applications within regions, within availability zones. Right? So we'll see how you can connect those regions back to your on-prem infrastructure. We also have a global network. This is redundant 100 gig Ethernet network connectivity between all of our AWS regions, as well as our points of presence, and to direct connect locations. Now, we haven't talked about direct connect locations yet, and that's what we'll be covering in today's session. But those are colo facilities where AWS has presence, and you connect to AWS via those colo facilities. Now, in addition to regions, we have two more options. These are fairly new, but gaining a lot of popularity. One is AWS Outposts for really low latency applications where you say, hey, my data center is running in New Jersey and your nearest AWS region is in Northern Virginia, and it's a latency which I cannot tolerate. No problem. You can bring AWS into your data center. That's exactly what Outposts is. Right? We ship you physical infrastructure which you deploy in your data center, and you can launch resources onto it using AWS APIs. Then we also have a different model, the AWS local zones. This is where you get scalable AWS managed capacity, but in large metro centers. Right? So we can bring a local zone closer to you in a metro city, and you can connect. So it's like a smaller version of an AWS region. That's an easy way to understand it. Now, for this session today, we'll be focusing more on the AWS region connectivity. We have 32 new local zones available in 2022. All right. In this session, we'll be talking about data centers and branch offices. So let's start with data centers. Now, as we think about building reliable networks, there are key principles we want to keep in mind. Availability, resiliency, recovery planning. Right? It is important that any options we talk about is factoring in resiliency and high availability, and it's scalable. So for that, we have 3 AWS services, which we'll be talking about today. The primary 2 connectivity options are AWS Direct Connect and site-to-site VPN. But you also see AWS Transit Gateway in there, because AWS Transit Gateway has, in the recent times, gained a lot of popularity, and I see every customer adopting it. It's a way through which you can create really large-scale hub-and-spoke networks in AWS, and it also supports hybrid connectivity like Direct Connect and site-to-site VPN. So as we talk about the different options and look at different architectures, you'll see Transit Gateway in there a lot. Let's start by talking about AWS Direct Connect. AWS Direct Connect, you have the AWS cloud on the left. You have the corporate data center on the right. Now let's connect them. Now, in order to connect them together, we use these locations called the AWS Direct Connect locations. These are third-party colo facilities where AWS has presence. So we have an AWS router in there. These Direct Connect locations are connected back to our AWS regions through redundant fiber connectivity. Every Direct Connect location has connectivity to all AWS regions, except China. Next, you set up a last mile connectivity between your corporate data center and this Direct Connect location. So you can have presence in the colo facility, and if you don't, then you can reach out to your service provider or any AWS Direct Connect partner to get this connectivity set up. Now, once you have connectivity into the location, all you need to do is go to the AWS console and request a Direct Connect connection. When you do so, what we'll do is we'll ask you a bunch of questions. What speed do you need? 1 gig, 10 gig, 100 gigs, which Direct Connect location you're connecting into. And based on that, we'll give you a letter of authorization. Take that to the colo facility owner, and they'll set up a cross-connect. And once the cross-connect is done, now you have end-to-end connectivity, right? You have connectivity from your data center to your router, from your router to AWS router, and then from AWS router back to the AWS cloud. Now, there are 2 models for Direct Connect connectivity. One is dedicated and other is hosted. Now, what's the difference? Now, with dedicated, you are connecting directly into the router through your infrastructure, so it's customer managed. Even if you use a partner, the routing is managed by the customer. With partner managed, you're typically going to a partner, AWS partner, or even your service provider, and asking for the connectivity to be set up. So in this model, typically your partner already has existing circuits to AWS, and they're just going to onboard you onto an existing circuit. So it might be a case where your partner, let's take an example. Let's say it's Verizon or AT&T. They already have 10 gig set up to AWS, and then they can onboard 10 customers, 1 gig each, onto that circuit. There's no oversubscription. You don't have to be worried about that. But it is bundling multiple customers on a circuit. Or you might get a dedicated circuit, depends. But it's a partner which is controlling that. Obviously, your data center router is under your control, so you still have control over the routing. Now, in dedicated connections, you have 1, 10, 100 gig options. There's a concept of virtual interfaces, which we'll talk about that. That varies based whether you're spinning up a dedicated or a hosted connection. As you can see, dedicated connection gives you a lot more virtual interfaces, so that's something to keep in mind. And we'll talk about what a virtual interface is in a bit. Now, it's important to choose the right Direct Connect location. I'll give you an example why. So let's say you have a customer data center. Now, you wanted to connect to US East 1 region. Now, it's very evident just from this diagram that if you go with Dallas Direct Connect location, it's going to add some latency. And you don't want that. You want to choose your Direct Connect location, which gives you lowest latency to the AWS region. So you might as well choose a location which lies physically in between the AWS region and your data center. So in this case, Virginia is a much better option. Now, obviously, this map is not accurate. That's not where Virginia is, but that was just to prove a point. Now, we saw the option, you have 1, 10, and 100 gigs. A lot of customers start with 1 gig, but they're like, hey, we want more capacity. An easy way to get more capacity or bundle capacity into one logical connection is link aggregation groups. It's not anything proprietary to AWS. If you have been working in the networking field, you probably know what link aggregation groups is. AWS Direct Connect also supports it. But if you're new, the idea is simple. You request multiple connections. So these will be multiple cross connects between your router and the AWS router. And then we bundle them together into one logical entity. So from the console standpoint, it'll look like it's just one large connection. So here we have 4 connections. If let's assuming there are 4 10-gig connections, you get a bundle capacity of 40 gigs per second. Now keep in mind that from a resiliency standpoint, a link aggregation group is a single point of failure. So if you want redundancy, and that's what you want to achieve, then this is not the right way to do it. And we'll talk about how you achieve resiliency in a bit. This is just a great way to get more capacity. Another new functionality which we have on Direct Connect is MACsec. MACsec allows you to encrypt traffic between your router and the AWS device. It is layer 2 encryption. It's MAC layer level encryption. And it's between the Direct Connect device and your customer edge device. This is available for 10 gigs and 100 gigs select Direct Connect locations. Now, that was between your router and AWS device. Now, how about within AWS and between the AWS Direct Connect location and the AWS regions? Now, what we do is, by default, we are encrypting traffic between AWS facilities. So in this diagram, which you see here, we have 2 regions. Within a region, between 2 secure AWS facilities, all traffic is encrypted. And between regions, the traffic is encrypted as well. So what this translates to is, if you have a VPC and you're running the latest generation Nitro-based instances, all traffic between them is encrypted by default. Between your VPCs, that's encrypted as well. And if you're using Transit Gateway and you're peering them, that's encrypted as well. So we are encrypting all the traffic within the AWS region. So let's look at the encryption story here, right? So you have MACsec support. So you're encrypting traffic between your router and AWS. And between AWS and our regions, traffic is encrypted. Additionally, if you want additional encryption, you can use TLS. Even further, if you want more control at layer 3, you can set up an IPsec encryption. That's a layer 3 VPN protocol, which you can use for encryption. And finally, if you want even more control, then you can use some kind of a software VPN or some kind of a additional encryption device, which is a logical appliance which can run in AWS, and then you can use that to encrypt traffic. My recommendation would be start with MACsec, because AWS already encrypts your traffic. MACsec is giving you the ability to encrypt traffic between your router and AWS, which gives you sort of the end-to-end encryption. And for more compliance reasons, if you need additional additional encryption, then TLS is, I think everyone's using TLS. So that's sort of given. But if you need more, then you can look at the other options. But I would recommend sticking with 1 and 2, because 3 and 4 adds more complexity, which you want to avoid. OK, so we talked about physical connectivity. We talked about encrypting your traffic. Now, how do you get access to your VPCs and transit gateways over Direct Connect? So for that, we have the Direct Connect gateway. So on the left in the AWS cloud, we have a sample setup. We have a AWS Transit Gateway. AWS Transit Gateway can connect up to 5,000 VPCs. Here, I'm just showing a single VPC. We have 2 AWS regions. These are 2 distinct regions. Now, we want to get connectivity into our transit gateways and our VPC over physical network. So for that, we create AWS Direct Connect Gateway. AWS Direct Connect Gateway is a globally distributed, isolated router which sits in your account. The AWS Direct Connect Gateway gets associated or attached to the AWS Transit Gateways. Now, AWS Direct Connect Gateway can connect to up to 3 transit gateways across different AWS regions, right? As I mentioned, Direct Connect Gateway is a global resource, so it has access to multiple AWS regions. Connectivity between the Direct Connect Gateway and the Transit Gateway is all through our AWS backbone. Finally, you create a virtual interface. Now, virtual interface is where you specify a VLAN. Now, this VLAN is a tag which you'll use to tag all your traffic which you're sending towards the Direct Connect Gateway. And over this VLAN, you'll create a BGP session. Now, BGP session will be between your customer router and the AWS Direct Connect Gateway. This is a way for you to exchange routes. So the AWS Direct Connect Gateway is going to learn the routes from Transit Gateway. And within Transit Gateway, an option to specify which routes you want to advertise downstream. Direct Connect Gateway is going to learn them, and through BGP, which is basically a routing protocol, advertise those routes back to your router. You do the same. Your on-premises data center will have certain IP ranges. Your customer router is going to advertise that to AWS Direct Connect Gateway, and then AWS Direct Connect Gateway is going to propagate those to the Transit Gateway. And from Transit Gateway, that's you have full control on how you want to manipulate those routing. Once this is set up, once the BGP is set up, now the actual traffic can flow. Now, we talked about the connecting to Transit Gateway. That kind of a virtual interface is called the Transit WIF, but we have other options as well. Let's say you're not using a Transit Gateway. In that case, no problem. You can have the Direct Connect Gateway connect directly to the virtual private gateway, which is entity per VPC. And finally, we also have something called the public WIF, which gives you access into AWS public IP resources. So if you have used AWS and you're aware of these services, Amazon S3, DynamoDB, these are software as a service. So these don't sit inside your VPC, and they are sort of at a regional level service, and they have public IPs. So if you go and try to access S3 bucket, you do a DNS lookup, the DNS resolution will give you a public IP. And those public IPs is what's reachable through the public WIF. So we talked about 3 virtual interfaces, right? Private WIF, Transit WIF, public WIF. Let's recap. Private WIFs gives you access directly to your VPCs. One Direct Connect Gateway can connect to up to 10 VPCs. So as you're thinking about scale, you want to think about, okay, if I have 100 VPCs, how many private WIFs do I need, right? 10 in this case. With Transit WIF, you can connect up to 3 transit gateways. Each transit gateway can connect up to 5,000 VPCs. So you really get a huge scale here, right? So as I mentioned previously, a lot of customers are loving Transit Gateway, adopting it for scale. And finally, public WIF. With public WIF, there's no limit on how many AWS services you can access. What we do is we advertise over the public WIF through BGP the entire AWS public IP range. So you get access to anything which has a public IP. And again, as I mentioned, a virtual interface is the VLAN and this eBGP session. We support both IPv4 and IPv6. Let's talk about resiliency. Now, in the previous set of diagrams, we have been looking at a single Direct Connect location. Now, a single Direct Connect location is a single point of failure. Why? Because within that, you have a single connection. So if your router fails, if the AWS device fails, or if the co-location facility has a failure, power failure, a natural disaster, you lose connectivity, which might be fine if you're running dev workloads or just you're messing around with AWS. But if you're running production workloads, critical workloads, you need to have resiliency. So here I have a model where we are using 2 Direct Connect locations. This is called the high resiliency model. And within each Direct Connect location, I have a connection. And we are assuming that at your end, you have resiliency as well. So instead of using a single customer router or a single data center, you have multiple data centers where you can terminate your circuits. Now, this is an alternative model. It's called the maximum resiliency mode. And this is what we recommend for production workloads. Here, we still have 2 direct connect locations, but within each direct connect location, we are using 2 different set of connections, which are terminating on 2 different set of AWS devices. Now, we're also assuming that at your end, you have resiliency, so you have 2 customer routers in each direct connect location. Now, these resiliency modes also map down to our SLAs. So let's look at that. So AWS Direct Connect has 2 SLAs. We have 99.9 for what we saw was the max resiliency mode, where you have 2 direct connect locations, and each direct connect location has a single connection. And then we have 99.99, which was for the max resiliency mode, where you have 2 direct connect locations and 2 circuits per location. Now, keep in mind that this is important because single direct connect connections can have maintenance. Right? These are routers which require maintenance. So if you are using a single direct connect connection and that's all you rely on, there will be downtime. Maintenance are not rare, and they do happen, so you need to plan for that. We do help you. We do have a resiliency toolkit which you can use. We also have a resiliency, like a wizard, where it guides you on how you can get resilient connections, and you can also test them. So you can terminate one connection through this tool and then see if you're able to appropriately fail over to different connections. So that's very important to test as well. A worst case scenario, you can always have a VPN for backup. Now, once you create this multiple direct connect connections through different locations, how do you handle routing? Right? In this example, we have 2 different connections. So on the top, you have the customer network. On the bottom, we have the AWS router. Now, the AWS router sees 2 paths, and it has to make a decision. OK, which path should I use to get to the customer network? Now, by default, within a direct connect location, we can just load balance traffic. If you don't do anything, the traffic is going to get load balanced within a direct connect location. Now, if you want more control over that, you can use AS path prepending. So on the left, what you can do is when you're advertising your routes to AWS, there's this concept called ASN, which sort of uniquely identifies your network. You can prepend the ASN number twice on your route advertisements. The logic is simple. Using BGP, we say, OK, the advertisement which has the shortest path will be preferred. And the path length is basically the number of AS numbers you have. So in this case, we will prefer the path through router Z because it just has single ASN versus router Y is advertising 2 ASN. So that's a longer path. Now, if router Z fails, we can automatically route traffic via router Y because that's an alternative path. There's another option where you can use BGP communities. So with BGP communities, you can tag your routes with certain communities, and these communities have a logic: 7100, 7200, 7300, low, medium, high, and we'll always prefer the higher community. So as you can see in here, we will prefer the router Y with the preference high because that has a higher community. And if that fails, then we can fail back to using router Z. So you have these 2 options, and you must be wondering, OK, why do I need 2 options? Why, should I use prepending? Should I use communities? That's where this logic comes in. So if you're running the max resiliency mode or the high resiliency mode, we talked about using multiple direct connect locations and multiple connections within locations. So if you have multiple connections within a location, you can use AS prepending to influence within a location which circuit gets used. But if you want to influence which location is used, that's where communities comes in. Right? So it's not a either or. It's basically a combination of 2 which will help you design the right routing model for your infrastructure. So here we have the max resiliency mode. Let's try to understand that. So let's say you're advertising these a combination of community and AS prepending. So as you can see, we have 7100 with 2 ASNs, then we have 7300 and 7300 with 2 ASNs. What you see in the green will be the preferred path. Why? Because 7300 is higher preference, and it has a single AS number. Now, if that circuit fails, it will fall back to 7300 with 2 AS numbers, which is to your router 4. If those both fail, can anybody guess where it's going to go next? Customer router 1 or 2? 1, that's correct, because it's 7100 with a single ASN. And finally, if everything fails, I'm sure there's bigger problems to solve there at that moment, but then you still have customer router 2. All right, so now we have completed our discussion on connecting your data center to AWS. We saw how physical connectivity works, encryption, and we saw how routing works. I mentioned during my intro that, hey, if you have a factory and you have your data center, you can use AWS to connect them together. That's a relatively new functionality which you've introduced. It's a feature of Direct Connect. It's called SiteLink. It lets you create connections between your on-premises networks, leveraging the AWS global network backbone. So in this case, we have this map of the globe, and you have different Direct Connect locations. What you would want to do is connect your data centers, your factories, your remote locations to the nearest Direct Connect location. From there, using the AWS Cloud Backbone, you can route traffic between all your locations. So before SiteLink was a thing, a functionality was released, if you had a setup like this, where you had connectivity through 2 different Direct Connect locations into AWS, you have Direct Connect Gateway, you have VPCs, and you're communicating between them. And now you have a use case where a server X in one of your data centers wants to communicate with server Y in one of your data centers. And you wanted to use this infrastructure, and you send traffic to Direct Connect Gateway. Direct Connect Gateway would drop the traffic. It would say it's not meant for AWS. Why are you sending it to me? Very picky in what how it's want to route things. So we changed that. We're like, let's change that. Let's give customers functionality. So now you can go to the AWS console. If you have existing Direct Connect locations, by the way, you can enable that on your existing connectivity. You don't really need to set up new circuits. Just click this flag, and now you can route between your data centers. So AWS Direct Connect Gateway is the entity which is performing that routing and sending the traffic back down to a different Direct Connect location to your corporate data center. It's a full mesh. So once you connect all your locations to Direct Connect Gateway and you enable SiteLink, all your remote locations are merged into a full mesh connectivity. You can use hosted connections, you can use partner-based connections, dedicated connections, 1 gig, sub 1 gig, 10 gig, 100 gigs, doesn't matter. Right? We support all of them. You can use a private WIF. We talked about previously, you have another option where it's transit WIF, where there's transit gateway, you can use that. Everything is supported. As long as you're using Direct Connect, basically, you can go and enable SiteLink. Now, you can also use SiteLink for more advanced use cases. So it's very common where you are running your corporate network, you have your customer, you have your data centers, and you want to mesh them together. But then you are in business with a partner or a vendor, and you want temporary connectivity to them. You don't want to go ahead and create circuits from your data center to your partner or your vendor data center. If they have connectivity to AWS, you have connectivity to AWS, that's enough. What you can do is create a new Direct Connect gateway and then create additional virtual interfaces. They can create additional virtual interfaces, terminate them on the same Direct Connect gateway, and now you have connectivity. So your data center can talk to a partner or a vendor data center through AWS. Very common use case. And that can be completely isolated from your own corporate connectivity. And you can create more Direct Connect gateways if you wish to. Right? I think I talked about some of those limits of 50 private WIFs. So you can create 50 Direct Connect gateways and create multiple isolated networks. So just to recap, you have Direct Connect Gateway, which sits in the center. This is your hub. Then you have Direct Connect locations. All you need to do is connect from your corporate data center to the nearest Direct Connect location, and then create virtual interfaces to this Direct Connect Gateway. And now this Direct Connect Gateway, it's a global resource. So your data centers one data center can be in Australia, one can be in United States. And Direct Connect Gateway can route traffic through the AWS Global Backbone between your data centers. Obviously, it's available in all Direct Connect locations except the ones in China. So let's recap what are the best practices we're talking monitoring. So let's talk about best practices for monitoring Direct Connect. In AWS, we have this service called CloudWatch. It's a metrics and monitoring service. It's not just for Direct Connect, it's for all AWS services, but it has a great integration with Direct Connect. So for your Direct Connect connection, you can monitor your connection state, your traffic flow, so basically bytes per second, packets per second, ingress, egress, whether your connectivity is on. So in your physical, if you go and connect an Ethernet cable or a fiber optic cable to your router or switch, you'll see as a green light. And so you can also see what that light level is. And finally, if there's any encryption, MACsec, or if there's any errors, you can track that as well. At a virtual interface level, so that's when you're connecting to the Direct Connect gateway or into a transit gateway. That's where you can also, at a virtual interface level, track your traffic metrics, packet per second and bytes per second. Yeah, so best practices recap for AWS Direct Connect. Use Direct Connect maintenance notifications. We have a personal health dashboard, as I said. Maintenance is not rare. So you need to think about it, plan for it. You get notified through the personal health dashboard, so keep track of that. We talked about monitoring the Direct Connect connections as well as your VIFs. But if you're running production workloads, critical workloads, you probably want to monitor end-to-end, which means from your VPC all the way to your data center. If you are familiar with CloudWatch, we now have CloudWatch Synthetics and some other services which does your application level monitoring. So you can use some of that. Or you can just have your own custom logic to test network performance end-to-end. For quick failure and detection, because that's key, as we are talking about those multiple circuits, and if one fails, you can failure to another. There's a concept of bidirectional forwarding detection, which is a router level config, which we recommend you enabling because that results in quick failovers. Resiliency is key, and the best way to test this is through the resiliency toolkit failover testing. Obviously, configure a second Direct Connect connection or a backup VPN for resiliency. Awesome. Now I'll hand it over to Rizwan to talk to you about creating site-to-site VPNs.
Thank you, Sid. So we're going to now talk about some of the other options that you can actually use to connect your on-premises data centers, and primarily being VPNs. So site-to-site VPN, you have your corporate data center on your right, you have your AWS environment and your VPCs on the left-hand side. Site-to-site VPN is your standard IPsec VPN that has been there around for a long time. There are different ways you can actually connect to your AWS resources. Our managed service, one of them is the virtual private gateway, as Sid actually mentioned as well. And virtual private gateway is our VPN termination endpoint. So the option one you can actually use is to terminate on the virtual private gateway. That connection goes over the internet. You can also stand up your own EC2 instance within your VPC and terminate your VPN connection on that as well. Thirdly, you can also use AWS Transit Gateway as your managed termination VPN endpoint as well. And we'll talk about these in the subsequent slides a little bit more. And optionally, you can also use the accelerated site-to-site VPN that takes the traffic using our global POP locations, our edge locations, using our AWS backbone all the way to the region. So when you actually create your site-to-site VPN, each connection actually gives you two tunnels. And whether it's AWS Transit Gateway or it's on virtual private gateway, the reason we give you two tunnels is for high availability. it's important to configure both tunnels, and both of these tunnels actually terminate within 2 different availability zones, so that if there's an issue with one availability zone, you can still use the other tunnel independently and still be able to reach. For virtual private gateway, since virtual private gateway, each virtual private gateway connects to a single VPC, and as you scale more, you can set up more VPN connections. But as from a scalability perspective, you'll probably see that adding more and more VPN connections can be a little bit of a challenge. So we'll talk about how you can actually improve and solve. And once the VPN tunnel is actually set up, depending whether you set it up as a static or a dynamic or a BGP-based routing on the VPN, you set up your routing, and both sides can actually know how to reach the other side. One of the things to keep in mind is that for virtual private gateway, each of these tunnels is capable of 1.25 gigabits per second, and virtual private gateway also only does not support ECMP. So what that means is that even though you may have 2 tunnels configured, we will use only 1 tunnel at any given time until the tunnel fails, and it will actually fail over. Now, what about the high availability and resiliency? So just like we talked about for Direct Connect, we actually provide multiple tunnels, 2 tunnels per connection. But on your side, we also recommend that you configure multiple customer gateways, so that if there is an issue with one of your customer gateway, you are still able to access using the other customer gateway. So that's one of the best practice. Similarly, for Transit Gateway is also our managed VPN termination endpoint, besides doing other things. And once you actually connect your VPN connection, we give you the same 2 tunnels. Both of them land in 2 different availability zones. For high availability, you set up your routing, preferably dynamic using BGP. And both sides, based on the routing, then learns how to reach the other side, and you can reach your corporate data center over this VPN connection. One of the things with the Transit Gateway is that Transit Gateway actually supports ECMP. So what that means is that if you actually advertise the same prefixes using BGP with equal costs and metrics, we will load balance the traffic over both tunnels or multiple tunnels, so you can scale your VPNs horizontally and scale your bandwidth and go much higher than a single tunnel can actually give you over 1.25 gig. Similarly, for high availability, we recommend that you configure 2 customer gateways, just so that even though Transit Gateway is a highly resilient, scalable managed service, but on your side, we recommend that you configure multiple customer gateways from an HA perspective, so that if there is an issue with one customer gateway, you can actually are not down. Let's take a look at the VPN throughput considerations between the 3 options. Virtual private gateway, so it's a 1-to-1 connection. So 1 VPN connection, 1 VPC, because each VPN connection allows you to connect to a single VPC. Throughput per tunnel is 1.25 gigs. There is no ECMP support. If you decide to use your own EC2 instance as your VPN termination, you can certainly do so. However, there's going to be operational overhead to make sure that HA is your responsibility. Again, 1 VPN connection equals 1 VPC. The throughput would actually depend on the size, the family, the type of EC2 instance that you actually get. So you may end up getting more than 1.25, depending on the size and family and the type, and also what vendor-specific software that you use to run on that EC2 instance. And again, similarly, ECMP support will also depend on the vendor. For Transit Gateway, as we saw, 1 VPN connections, many VPCs. As I mentioned, Transit Gateways can scale up to thousands of VPCs in a region, up to 5,000. So you can, using a single VPN connection, reach, using a Transit Gateway, up to thousands of VPCs within the region. The throughput per tunnel is still limited to 1.25 gigs, but you can use ECMP with dynamic routing. Remember, ECMP is only supported with dynamic or BGP, not with static routing. So you can horizontally scale and easily go up to 50 gigs across your VPNs. All right, some of the best practices for VPN connections. As we saw with Direct Connect, VPNs emit CloudWatch metrics for your VPN. So things like your tunnel states, the traffic flowing through the tunnels, you can actually monitor, set up alarms and thresholds on that. And then notify if one or both of your VPN connections may be down. We also publish the notifications via the Personal Health Dashboard. For example, if there's maybe some maintenance happening on our side as part of the virtual private gateway, we will send out a notification to let you know. Or if there is a single VPN tunnel configured. So oftentimes what we have seen with customers is that even though we give you the option to configure 2 tunnels, you may end up designing only 1 tunnel. So we will notice that, and if we find out, we will likely just give you a proactive heads up saying, hey, we only see 1 single tunnel. It's good if you actually configure both from an HA perspective. So you'll also receive those notifications via the personal health dashboard. Some of the other best practices, always recommended to use BGP for dynamic routing, because BGP automatically detects the routing and how the peer is on the other side, and it can fail over much more quickly otherwise versus using static routing. Also use dead peer detection. The standard on our side is 30 seconds, so that if the customer router doesn't, or we don't detect a heartbeat, so to speak, within the timeout period, we will automatically, the peer will automatically assume that the connection, the other side is down, and it will actually close down the connection. And last but not least, configure both tunnels for your VPN connections. So let's talk about connecting your branch offices. So as we talked about earlier, the third option in the VPN story is the accelerated site-to-site VPN. It is an optional feature that you can enable and is only available on AWS Transit Gateway, not on Virtual Private Gateway. And what it actually allows you to do is use over 100 of our edge locations throughout the globe. So for example, you have your corporate data center, let's say somewhere in New Jersey, and you actually create a accelerated site-to-site VPN, which is as simple as a checkbox within the console when you're actually setting up the VPN configuration using Transit Gateway. And the traffic is actually, the traffic enters via the closest edge location in this case. So the closest edge location is, let's say, also in New Jersey. So rather than going over the internet, the traffic will enter from the closest edge location, and then it will actually ride all the way over our AWS backbone, which is an optimized path, congestion-free, to reach your resources within the region. So it gives you much better performance versus your VPN, which we all know go over the internet and can be subject to what we call internet weather. The third option is SD-WAN, which we call AWS Connect. And typically, SD-WAN is a very popular option, especially if you have branch offices or otherwise. And in the past, what you could do is you would deploy your third-party SD-WAN appliances within AWS, and then run site-to-site VPNs between SD-WAN appliances and AWS Transit Gateway. And then connect to the SD-WAN appliances from your corporate data centers or the internet, et cetera. And in order to simplify, we released AWS Transit Gateway Connect. What it actually allows you to do is to use GRE instead of running IPsec tunnels. So you deploy your SD-WAN appliance within a VPC. Let's say in this example, it's called Connect VPC. And then you attach that VPC to your AWS Transit Gateway using VPC attachment, create a Connect attachment, and then create a GRE tunnel that uses BGP to establish the peering between the two sides. And then from your on-premise data center, you can then connect to this SD-WAN appliance, either using AWS Direct Connect, which becomes the underlay, or over the internet. Either one is fine. And then BGP then exchanges the traffic between the two sides, and both sides know how to get to the other side. So from a scale perspective, just like we talked about VPNs and direct connects, high availability is important. So you can actually deploy multiple SD-WAN appliances within the Connect VPC, establish your GRE tunnels between the two, and then do the connectivity to your corporate data center or direct connect or the internet. And the idea is that if one of your SD-WAN appliance goes down, you still have connectivity using the other one, using the same AWS Transit Gateway. And we also allow to use ECMP between those connect attachments, so you can load balance the traffic between the two sides. Same thing as you can see here from AWS Direct Connect. You establish your Direct Connect connection from your corporate data center, and let's say your appliance is also on-prem. Establish your Direct Connect, and then run a GRE tunnel between the two sides to establish the connectivity. GRE also actually gives you much higher prefix scale. So as you can see from AWS, you can advertise up to 5,000 prefixes towards your on-prem, and advertise 1,000 prefixes from on-prem to AWS. Some of the from a scaling perspective, the maximum bandwidth that you can actually achieve on a GRE Connect attachment is up to 5 gigs that you can scale up to four attachments and up to 20 gigs. And maximum packets per second per connectivity peer is 500,000 PPS. Let's talk about connectivity to remote users. So one of the common, especially in these days with almost everybody, majority of the people are working remote, is to use TLS-based remote access. And in that arena, we have AWS Client VPN, which is our managed TLS VPN service that allows any remote user to be able to securely connect to AWS resources or a OpenVPN compatible client. So you create your client VPN endpoint within your target VPC that creates elastic network interfaces within the VPC, and each elastic network interface terminates or gets created in different availability zone. And again, this is for high availability. And then any OpenVPN compatible client, or we also offer our own AWS client. Your users who could be mobile devices or desktops can then securely connect your AWS resource within the VPC over this endpoint. And not only that, using the client VPN, you can also access other resources which may be connected behind a AWS Transit Gateway or a peering connection, or even your on-premises connection. You can also use authentication using Microsoft Active Directory, SAML, or certificates to authenticate the clients. You can additionally also use AWS Lambda as an additional sort of like optional layer to do, think of it as a posture assessment to allow or deny a user based on where they may be coming in, what kind of operating system they may be using, what is their IP address as well. And you can also use authorization rules to restrict access to which user who actually connects to the network via the client VPN can then access the network behind it. Some of the best practices, again, use authorization rules to restrict users who can actually access, use security groups to allow or disallow your users who can access your Amazon, your VPCs. And then also you can use client certificate revocation list to revoke if, let's say, somebody actually leaves your organization. You can revoke the access, and that way they can not able to access. And then lastly, you can use CloudWatch metrics to monitor your status of your client VPN. With that, I'm going to hand it back to Sid.
All right, last 1.5 minutes. Let's do it. So we saw Transit Gateway. We talked about Transit Gateway being a resource which can connect up to thousands of VPCs, but it's a regional resource. So you want to set up a global network, you peer Transit Gateways together. This looks complex. I'm sure we can simplify that. That's where Cloud WAN comes in. It's a new service which we released. So you get rid of all of this mesh peering in between the complexity and replace it with Cloud WAN. And now Cloud WAN, within that, you can create multiple segments, security segments, and connect your VPCs to it. You can also connect your on-premises networks to Cloud WAN through Transit Gateway Connect, AWS VPN, and other support coming soon. This is available in public preview. We released that at reInvent last year, and we are expecting this to go GA later this summer. So you can use Cloud WAN to connect between your VPCs for WAN connectivity, as well as a mix of everything, right? So Cloud WAN basically allows you to create your global networks, simplifies it, adds security over it. It's a great service to use. So if you're interested, definitely check it out. We also talked about SiteLink, which was connecting your data centers together, right? So you can use Cloud WAN, you can also use Direct Connect SiteLink, or you can use both. There are different use cases for both. Obviously, Cloud WAN has, if you just want to connect between your data centers, I would say SiteLink is better. If you want more feature functionality, Cloud WAN is better in that case. Again, recapping today's what we talked about was connectivity to your data centers, connectivity to your branches, and then obviously touched on the global connectivity. Thank you for coming. If you want to learn more, we have AWS certifications, online courses. Definitely check them out. Thank you. Please complete the session survey. That's how we get graded, so 5 stars.